So let me get started. So hello, everybody. This is our weekly Wednesday live that we do on Wednesdays, 9 o'clock here in California. And I see people from around the globe. I see David Kerrigan joining us from Ireland. Charles is there from Nigeria, and Oluwatobi. We have an international mix of people. That's the beauty of this. And I see a set of my students also here. So we have our new class. It's called PathtoAV. And the first class is AV Master class that we started yesterday. The second class is Business of AV Data that I will start teaching tomorrow is the first session. So my students from all the different classes also come in for these sessions when we have an external speaker. So with that, I'm going to pass it on to Mr. Alex Foessel. He is an expert in smart agriculture space. And I had the opportunity to hear him speak at IoT Innovatec Chile, IoT Innovatec Latam in Chile. And in fact, he was speaking in Spanish and I had to wear a headset and get a translation. And of course, I had a chance to talk to him, interact with him a little bit. So I'm very fascinated to hear him talk to us and talk to our students and answer questions, because he's an expert who has digitized the agriculture space. And when I've been talking about, self-driving cars and how autonomous vehicle space is, more than the car space, and it's trucking and devices and, instruments and robots everywhere. The fascination is we have had the digitization of the car going on for a long time. And John Deere has been running and testing driverless tractors for as much time as Google was testing their self-driving car. And Mr. Foessel is one of those brains behind John Deere who has helped their digitization, automation, and AI. And I will let you tell him about this space because it's more than John Deere. He's looking at the overall space today. So with that, let me hand it over to him. And thank you so much for joining us, Alex.
How, Sudha, thank you very much for your introduction. And first of all, I would like to check that everyone can listen to me. Sudha, are you listening well?
Yes.
Okay.
Yes, we can.
Very good. So thank you for the introduction. And one thing that I would like to clarify is that since January, I parted ways with John Deere. And I have been having a fantastic time in the sense that my interests have broadened quite a bit.
Okay.
As I left, I had interviews with some of the executives, and I have a very long list of tasks and initiatives that I should put myself to work. So I continue to contribute in this fantastic John Deere ecosystem, but moreover to really add value to agriculture, mostly in the Americas, where I have spent most of my time.
And where are you joining us? Where are you joining us from today?
I'm in Chile.
Okay.
I was in Brazil up until mid-March, and then that's the time when the pandemic started to hit South America. Yeah. And Chilean government started closing borders, flight cancellations, etc. And I took one of the last flights out of Brazil. To Chile. I'm here with my children. My children live in Chile. But just next Tuesday, I'm flying back to Brazil to resume my consulting business and venturing and investment business. And then after a couple of weeks, I'm going to head back to Pittsburgh, Pennsylvania, where I am going to be residing permanently. In any case, thanks for the opportunity. I'm going to have a very casual discussion that is going to look into how agriculture has been changing. And I'd like to make a correction. John Deere has been testing autonomous vehicles way before Google started testing cars. I just want to make sure that that is corrected, because I have been part of that journey that in the last 20 years, John Deere has had in terms of automation. So just a couple of things. I've been working in, I have a PhD in robotics from Carnegie Mellon, then been working for John Deere for about 18 years in technology development, business development, also commercializing actual autonomous products. We're going to talk a little bit about that. And then in Brazil, in Germany, then in Brazil, I've been for 5 years working on technology innovation for ag. And then I spent the last 2 years working in John Deere for the next generation, leading the team that was developing the next generation architecture. As I said before, I am no longer with the company, but very close. And you will see a presentation that shows mostly John Deere equipment, but what I'm going to say probably applies broadly to other ag OEMs. As for question and answers, what I would like to propose to the team, to everyone who is listening, there's a chat, and I have another window open here. Just type your questions, right? As we go, and as I see them coming, I will maybe pause to answer them, or I may answer them later. And I'm going to make sure that we leave a little bit of time at the end so we can have a dialogue. And Sudha, I count that you are going to help me manage that conversation.
So we have till 10 o'clock. So, I mean, we have till
very good.
Another 45 minutes. Yeah.
Yep. So let's try to keep this.
And focusing on the asset part is really good because we are covering digital twins in the next session that starts tomorrow when we are talking about business of AV data. It's more about connected car and autonomous vehicles. And in fact, I have one of my students, Sneha Jadhav, who's here. She's got experience in digital twins and very passionate about that area.
Okay, well, that is interesting. I'm going to touch on the topic of digitalization and how digital twins are becoming very, very important for development of highly automated and autonomous machines. But also in our world, the term digital twin relates also to the representation of the actual production, crop production, and the creations of agronomic models that enable us to make better predictions and help our customers with their decision making. So tell me, are you able to see my screen? It should say physical meets digital.
Yes.
This is a subset of slides that I presented last year in Pittsburgh during the IRI, which is the Innovation Research Interchange, an organization of about 200 companies that joined to talk about topics related to automation, innovation, digitalization. So this is a subset of that presentation. Let's go back to something that is very basic, farming 101, I'm going to say, right? And let me step back one thing. We have roughly 7 billion people. We're going to be 9.5 billion people in 2050. And the question is, where's that food going to come from, right? And it's going to come mostly out of technology, because as it relates to the expansion of area, globally, we do not expect more than 20% expansion of area, but we will need to see at least a significantly more increase on the production of food than the expansion of area. So the additional food produced will have to come from technology. And that's what motivates my work, and should motivate also everyone else who is in digitalization and autonomy, consider off-road and ag as potential areas of development. The traditional crop production has 4 phases. You have field preparation, which is what is up on the left. That's where we prepare the soil to receive the seeds. Then on the upper right, you have plant and seeding. And then on the lower right, you have apply. And this application could be chemicals, could be fertilizer, could be a number of things, or even could be mechanical weeding. And then eventually you close the loop when you have harvesting, which is the lower left example. We can have many variations. There's a number of, this may change significantly depending on the crops, where they're perennial, semi-perennial, etc. But roughly, this is a good set of steps in crop production that helps us to understand the complexity the complexity of this production system, because what you do in the preparation of the soil is going to have an impact into the quality of the seeds, but then the emergence of the seeds is going to have a significant impact both in how the plants grow as well as in what is going to be the ultimate yield. Farmers attempt to do two things when they look at this production system: maximize the yield, because that is what they sell, and most food producers, crop producers, farmers typically are price takers. They are going to sell a commodity, and that commodity will sell by whichever is the market price. So the way for them to increase the revenue is to increase the yield. At the same time, to increase the profitability, they work a lot into reducing costs. And when we think of the cost of the seeds, very specialized seeds, planters need to have the technology to guarantee the germination. When we look at the inputs that come in the case of chemicals and fertilizers, those are also expensive, and so forth. So the more that technology can help increase yield and reduce operating costs, that is going to give our farmers most profitability and sustainability of their business. So there has been a number of changes over time, right? And this is true not just for John Deere, but others, where we have had, mechanization when we used to have implements that they were pulled by animals, oxen or horses. Then the engine comes along, and then we have the start of the mechanization of agriculture. Eventually, GPS becomes a key enabling technology for the hundreds of thousands of vehicles, both John Deere and others, that are roaming with high precision, providing with maps, with data. And that data eventually becomes available through connectivity. And again, the numbers are hundreds of thousands of vehicles that are connected today, and they're becoming not just harvesters of grains, but harvesters of data. And the next phase is really the automation that is coming there. So let me quickly see the okay, that is used to typing data. Okay, got it. So what is happening is that we are facing a transformation where up until, I would say, the last decade, and of course still to some extent today, but not so much, it was always about building bigger, faster, and stronger machines to multiply the time of the operator and to enable our customers to achieve more acreage in the same time, or to achieve a given amount of acreage. Let's say if you're planting in narrower time, use the weather windows. This is really changing by GPS enabled not only the guidance and the precision of driving of these machines, a tractor, a harvester, a sprayer, but also enabled to start gathering data and understand what was applied or what practice was done in a given piece of terrain. So now we have georeferentiation, and we have all the data referenced to a common position. So now if we try to understand what is the process of growth of a plant, the agronomic process, and things from one year to the next, we can start making better decisions. And that is where the magic starts. And now the focus today, most of the investment is not going into larger pieces of equipment, but into more technology, more analytics, more connectivity, and also more controls. So we can take all that data, turn that into prescriptions. And also another area that has developed quite a bit is the user experience, the user interface, because it doesn't help our farmers to have highly capable machines if you need a PhD to run them. So the complexity of the technology needs to be hidden behind very good user experience. I'll get to the driverless tractor in ag motivation in a moment. Let me keep going so we build up the case to answer that question correctly. So sensors, communications technology, real-time data, GPS, operations center, that is a digital platform, not the only one, mobile technology. So one myth is that tractors and ag equipment is old, obsolete, without really much technology. And the truth is that any of these tractors may have 11 or more high processing power controllers. And as we're starting to mount machine learning, as we're going to see in an example coming up soon, then we're having not only high power controllers, we're having controllers and computing that is able to process several video streams for obstacle detection, for precision driving, for safe driving. But as you will see, machine learning is also starting to help us with the quality of the job. And I would like to make a comment related to tractors, autonomous tractors versus autonomous cars and autonomous trucks and others. Most of the on-road automation and autonomy is helping do the job of moving from A to B in the fastest, safest, and more efficient way. When we talk about ag and automation, no one goes tractoring around. The jobs will be tilling, planting, applying, weeding, harvesting, managing the residue, excavating, and so forth. So what I'm trying to say is that whenever you think of autonomy as something that is going from A to B, that is fine if you're thinking that that is fine when you think that the job is to go from A to B. In the case of any particular agricultural machine that you're automating, the path is just the function of the job that that machine is doing. So the tractor is not going to where it wants to go, it's going to where it has to go, so the implement does the agronomic job. And the diversity of jobs is something that is complex, has a lot to do with the yield and of course the costs. And it's something that whenever I hear, and I've met with many, believe me, companies that say, hey, John Deere, we have an architecture that is going to solve the autonomy problem for ag. My first question is, okay, how is your architecture and your systems going to help me plant better? And that's the beginning of the end of that conversation, because most of the automation and autonomy stacks and technologies that have been developed are to go from A to B, but that is just one function that automation in ag has to do. There's all the stuff of monitoring the understanding when, for example, a plugging has occurred, or there's a problem with a planter and seeds are not dropping. All of those aspects are as important as to make sure that the machine drives safely over a large field. But let's get in a little bit more to the digitalization piece. I was telling you that now we have more and more data, and this is really a pivotal time, because up until now, most of the decisions around ag have been taken by getting experts. Typically, it's the farmer, maybe his manager, and then you get an ag consultant, and then you may bring also your dealer, and then there's a couple of other people who bring the salesman of inputs, etc. And there's a good conversation, some thought about what had happened last year, and then decisions are made in terms of what crop to plant. Usually there's an economist there, someone who knows about prices, by the way. And it's a good conversation, and then there's a decision that is being done for a full field. In this field, we're going to plant soybeans. It's going to be of this variety, and the year seems that it's going to come wet, so it's going to be a variety that grows very well with water, and we're going to put some fertilizer, and then later apply to prevent weeds and disease. That is changing significantly. For the next 180 years, is going to be on data, based on analytics, based on agronomic modeling, and instead of making decisions field by field, we're making decisions plant by plant. And that's the beauty of it, because now we can start optimizing not just the complete field, but actually we can start optimizing the growth and the yield of each plant in a large field. So where's agriculture heading in terms of this area? Car technology, car automation is investing billions of dollars, and that is resulting in more and more technology. Computing is becoming more affordable and smaller and more rugged, so we can put more and more computing. Mobile is also changing the way that humans interact with digital systems. And also machine learning is getting out of the labs, is becoming used in a number of fields, but also we're starting to see the first great applications of machine learning in ag. So let me see if we can just talk a little bit about this particular product. This is not exactly ag, but the reason I wanted to mention this is that this is today the only product that John Deere sells that is fully autonomous. It's not very intelligent, but the key lesson is that 10 years ago, we started selling thousands of these machines and they were not connected. I think that none of you today would start any program that would bring automation to any piece of equipment, ag or not, that would not start by being connected. So right now, when I left John Deere, a lot of the focus was to improve this, but before getting improved, the first thing is to get it connected, because with data, you can improve the product performance, you can improve the product itself, and you can improve the overall operation. Same thing is happening with agriculture. Another trend that is helping this digitalization has to do with the innovators, the venture funds. And here you have, and by the way, this is old news by now, this was last year. Agtech startups have raised significantly more than that kind of money in the last 5 years. And it only goes up. Only in Brazil, there is more than 500 fairly stable growing startups in ag, only in ag. And here we see a number of companies that may be somewhat familiar to you. There's one that is called Blue River that you see in agricultural robots. That is a purchase that John Deere did for about $300 million. And right now, John Deere is working really, really hard into integrating their machine learning technology, and I'm going to show you a video. Let me get to that. Oops. Let's see if this plays well. This is one example of what John Deere is doing in terms of automation to try to reduce the amount of chemicals. This is not autonomy. There is a person in the vehicle, but what you're going to see is how GPS mounted on the tractor and GPS mounted on the implement, controls, and also cameras are enabling really, really, really fast mechanical reading. And this is becoming very popular in Europe, because in Europe you have quite a bit of resistance to the use of chemicals to control weeds. And here what we're seeing is mechanical tillage equipment that is actually enabling the machine to go real fast. I hope that the video is playing well. If not, it's going to be embedded in the presentation that I will leave with Sudha. So that is one example of automation, right? But let's get to something that would be more interesting, because that is automation, that is good controls, that is vision guidance, vision processing, but machine learning is what's going to give us the next level of performance. This next video is going to show the integration of Blue River technology, the acquisition that John Deere made a couple of years ago, in order to distinguish between cotton plants and actual weeds. So what you will see is that the cameras underneath this structure are looking down, are taking pictures, video of each one of the plants, and based on a neural network, the machine, the system is making a decision, is that a crop or is a weed? And it's a weed, it triggers the application of a chemical that kills just that particular weed. Now, this is technology that has the potential of creating a significant savings. And I want to go back to what we discussed at the beginning. That is, our farmers are trying really to reduce their operating costs, and that goes through reduction of the inputs, the chemicals, the fertilizers. So that is a good example. Let me. I'm going to play it again while I finish the explanation here. So when you apply today chemicals, many times you apply chemicals to a field in a way that it would be comparable to see that if there's a city and you find a few people with some kind of infection, then you would apply the vaccine or antibiotics to everyone in that city. That is wasteful, creates resistance, and that's why technologies like the one I'm showing right now are going to be fundamental for the sustainability of the farmer's business by reducing the costs with much less chemicals applied, but also is going to increase the sustainability of agriculture because we're going to be putting less chemicals in our environment, and we're going to have soils that are going to be healthier long term. So in terms of the digitalization, really, many people thought, well, data is what is what comes out of machines. Machines are capturing data. That is what's coming out of the field. Not really. Data is becoming the fuel for better decisions. So what John Deere and others are doing, we are capturing all the data, every pass, all the passes. So when we till, when we plow, when we plant, when we apply, all of that is being captured in terms of the application itself, the data, the operation of the machine, etc. And we expect that overall equipment is going to become more smarter, because all this data now is being collected in a digital platform. In the case of John Deere, it's called Operations Center. There are others, but for example, in the case of John Deere has more than 100 million acres of valuable data of with 1 or more years of accumulating this data, which is available because this platform is has APIs that enable many companies to come in, take data out with the permission of the owner of the data, which is the producer, use the best analytics, and then feed back data decisions that can be used to improve the overall operation and the profitability. So up until 2018, there are more than 100 companies that are connected to this digital platform, taking data out and using the data to bring back in insights, decisions, prescriptions to make our customers more successful. John Deere was at CES in 2019, in 2020, and really this is a play that John Deere and other companies are doing to say, hey, come and work with us. We have a technology. Our farmers are asking for more technology, and this is something that I'm going to tell Sudha, with your permission, to everyone in this audience. Come and work in ag. There's a lot to do. There's a lot to be gained. There's a lot to contribute, a lot of value to be created. And by the way, it's a very noble purpose to feed the world. Let me take a show here how this becomes a vision. And after this, we're going to start talking about Q&A. So that you wanted me to show what John Deere is doing. I think that this video is going to really put it all together. It's going to last.
The front should pass by midday. Based on drainage and when the rain stops, we should be able to start spraying by
Are
end
you
of day.
listening to the audio of the video?
Yeah. You're on his way back?
Yeah.
He said he was checking on the boys.
All right.
Message from Walker Keane, John Deere dealer.
Hey Drew, updated and checked your combines remotely. All machines are optimized for harvest season.
Message to Walker. That's great. Thanks. Send.
Message sent.
Kate, did you see the latest?
Looking at it now.
Dad's, worried.
With the solutions I see here, he'll be better. How are the boys?
They're working where we can't, and they'll be on it all night.
They'll get it done.
Your machines are set for projected yield and moisture. And we're also updating firmware on Harvester 3 tonight.
That's great. Hey, let's take a look at fields 5 and 6 tomorrow. We may want to make some changes there.
Yeah, sure thing. We'll check in tomorrow. Have a good one.
Thanks. You too, buddy. Go to field 5 and aggregate all. Mark.
Aggregate field 5. Recommendations. Phosphorus nitrogen application on sections 2, 8, and 27 with health predictions.
Go with solution 2, field 5.
Solution 2, field 5.
They look great.
Mm-hmm.
With the weather, prices are up by 10 cents at the elevator. You want to sell?
It's not bad.
Yep. Shall we?
Let's do it.
Okay, very good. So I thought that I would provide you some key takeaways, and then Sudha, let's open it up for questions and answers. And I will certainly address those that are on the screen. Couple of things that came out of our interactions with customers and others is that one thing is that we have new generations of farmers, and the new generations have been exposed to, technology all around them in their lives. What is happening is that what is happening right now is that they want to see that their business is also portrayed as not a, antique, old, low technology business, because right now ag is not anymore a low tech. It is really high tech and is drawing investment, innovation, and technology as any other field. The other thing is that autonomy is a journey, and really is a digital one. Digital is inevitable. Digital is here to stay. Digital is going to provide the data to justify and to drive automation. Also, as I just mentioned, it comes first, right? Up until now, we didn't have digital, so we always worried about the products themselves. Now it's all about the operation. The human factors key piece is key. So we want to see that technology is really hidden behind very simple to use interfaces. And the other piece that is going to come is that every farmer has his own ideas in how they want to produce, and solutions in the future will have to continue to become more and more personalized, much more to compared to what the products are personalized today. So that's what's going to eventually help us produce that 70% additional food that I mentioned at the beginning, 2050, because only 20 is going to come from the area, all the rest is going to be productivity out of technology. Thank you.
That's fantastic, Alex. This is amazing. So I let people ask questions because I was writing notes and you answered my question about the.
Yeah, there's one that was question: what motivated driverless tractors in ag? Okay, so again,
can you come back? Sorry, can we see your picture or image? Your video?
Absolutely, yes. I will get there.
Thank you.
Stop share.
Yeah, and people, if you want to, turn on your camera also, it's fine.
Yeah, I'd love to if you want to show your faces. It's always cool to see smiles.
Yeah, I can do a screenshot, group picture if you want.
Well, in any case, let me talk a little bit about the motivation. Remember, this is not a chase to autonomy directly. It's not jumping to autonomy. What you see in ag is the digitalization that is providing the data and the justification for increasing automation that will eventually end in fully autonomous tractors and others. But the key thing that we will need to remember is that before we have a full autonomous tractor, we need to have a fully automated implement. If we want to get to a full autonomous tractor, we need to have automated the functions of looking and understanding how the implement is doing, how the operation is doing, how to interact with potentially other vehicles, how to deal with exceptions, how to deal with, for example, terrain that may be very wet, and if the tractor is not smart enough or can deal with those exceptions, then we're going to see a tractor that is going to get stuck. So there's a number of functions that, first of all, are required to do the agronomic job well. That is number one. We need to continue to improve the quality of the job. And driving, once again, is just the function of doing a quality job. So I am positive that we're going to see fully automated machines. In fact, in some cases, very small machines that are the ones that have the size and the low pressure to go into very wet areas to apply chemicals at the right time, like those robots were doing in the video. So job quality, accessibility of terrain, right timing of application are some of the key things that are going to motivate driverless tractors.
Alex, Usha has a comment about insects, tracking insects. Is that something that is happening in your world that you're seeing?
Yes. And I would say that there are several startups and also companies that are developing services to actually capture insects and do analysis. So what they have is things that you put in the field that will attract the insects, and when the insects get in, cameras analyze what kind of an insect that is. That's a way to have early detection of plagues, early detection of infestation that could be treated, right, with chemical. But instead of applying the chemicals all over the place, this tracking of the insects enables a much more precision and tailored application. Did I answer your question?
Yes.
I would like to, let's see, let me ask that last one from Charles. Charles, I am one that I'm convinced that we're going to see full autonomy in ag commercialized before cars. Not many people agree with me, but when I look at the need for delivering much more productivity, and this may not happen in the US, by the way. This may not happen in the US because the US has an environment that has a lot of concern for product liability and accidents. In other countries, and I'm thinking Brazil right now, but this also applies to other geographies, the environment, the business environment is not so much about litigation, and there are other drivers that will make companies to adopt autonomy in ag. And I think that the autonomy for cars is going to come in very niche, very particular applications. So I don't know. It's hard to say, but I certainly would vote and make some bets that we're going to see autonomy in ag, possibly not in the US, even before we see commercially deployed autonomous cars.
Alex, I want to make a comment and then ask a question. So it's typical in industry with robots and a lot of other automation that industry funds it and does it in a safe setting for a very specific application. And then from the industrial setting, it comes to the consumer space. So is it possible that there would be, I mean, I'm building on Charles' point here. Is it possible that the automation and the right way of doing this could be modeled in agriculture, and then it can come to AVs? So do you see a cross-pollination happening across agriculture to other industries in terms of the ag tech?
Yes, but not in the sense that you explained. In fact, if you think about the risk profile, let's talk a little bit about the risk profile. When you think about what could go wrong in a car that is going 60 miles an hour down a highway with many other cars, or even a car that is going 30 miles an hour down a street with pedestrians and bicycles and construction, etc. In either case, coming to a safe state if there's a failure is very, very difficult, very expensive. That's why things such as functional safety and the safety of the intended function, SOTIF, if you're familiar with that acronym, is something very difficult to attain in the automotive world, because you need to deal with not only slowing down and stopping, but also many times the safe state is only when the car is outside of traffic. So to execute that with a car that has a problem, that has had a failure or something like that, you need to have a lot of redundancy, a lot of cost, etc. Generally, and well, I'm saying generally because this is not always true, but generally in a field, the field is dedicated, is empty, an ag field. You have a vehicle that is executing an operation, a task in the field, most of the time by itself, and moreover, the speed at which this is happening is very slow. So only if you let the throttle off, you probably are going to come to immediate stop. So what I'm trying to say is that the levels of redundancy and the levels of product functional safety that you will need to get a fully autonomous tractor is going to be much less than in the case of a car. At the same time, I already spoke of the complexity of managing not just the driving, but the implement, the rest of the operation, etc. There is, however, Sudha, to your point, a lot of cross-pollination that happens in terms of the investments in computing, cameras, sensors, software platforms, architecture that can be reused. So, for example, there are companies that provide a very tailored. So, for example, the company that provides the computing package for Audi is a company that is making is a Austrian company, TT Tech. They're making really, really good progress in taking the computing and the safety aspects, etc. They have developed for automotive and create a dedicated off-road computing platform that uses the principles of safety from automotive, but has reduced the cost of it because the problem that we're trying to solve in ag is a bit less complex from a risk point of view. Sorry, that was a really long answer, but you touched on the dimension of the cross-pollination, and I needed to address the risk level, and this is different for the two industries.
No, it's actually very good, because one of the topics that there's David Kerrigan in here from Ireland. He is my co-instructor in the AV masterclass, and he covers regulation as one of his topics. And I always question the need for regulation. We know that it is important, but in US, we push back on regulation in the AV space, right? The companies don't want too much regulation. They want freedom to innovate. So the innovation versus regulation is a challenge that we have here. So your point that we will not be able to see as much speed of innovation in US because of the risk is an interesting perspective. In fact, Usha, who's been chatting and asking questions about agriculture and spotting insects, is actually from insurance tech background. And
okay,
so it's very interesting to hear that validated. So thank you for that.
Quick. I see many startups with drones looking at fields and using computer vision, machine learning to identify which and what plant has been blah blah. Yes. It says my students would love to help make sense of this data to create business value. I would invite you to go to developers.deere.com and take a look at the infrastructure that Deere has set in terms of APIs to access that data. If there's some interest, I could make the contacts internal to John Deere to see how this could be pursued.
Yeah. Okay, we'll take a look, and I will follow up offline, because one of the promise with this PathtoAV program is after students learn the foundation, we are promising that they would get to work with real industry on a capstone project. So I'll follow up offline, but we'll do our homework before we come to you on that.
Absolutely, absolutely. As you can see, I have a lot of passion for this.
Yes, very contagious. I could see that. Yeah.
Then, so the link was not correct. Let me take a quick look here. I think I may have been developer.deere.com. I used to have a sticker on my computer that would tell me what the actual. Let's see if this opens up. Ida, thank you for your comment about Pittsburgh. I spent six years in Pittsburgh as well some time ago. I'm really excited about going back to that city. Excuse me, is developer, I'm going to copy this.
Okay, Anand has actually found it. He's very good. It's one of his superpowers. In all our classes, he always finds every reference link that is mentioned in the class. It says it's developer. It's not developers. It's developer.deere.com.
Yep. Tractor to tractor communication. It's making progress. I'm going to make a broad comment. I think that a lot.
Can you read out the question and then give the answer? Because
yes, sorry about that. Yes. Sneha. Thank you. So she's wondering about the machine-to-machine communication advancement in ag industry. So what I'm going to say is that it's moving. So first of all, we had radio links coming down from GPS satellites and Inmarsat satellites to just create the precise positioning. Then later on, we have cell phone modems that connect machines to the web and to the internet. The challenge we have is that not all rural areas are well covered with with cell phone signal. So there's a tremendous opportunity to continue increasing the coverage in the US, but moreover in other places like Brazil, Africa, etc. Europe has a higher level of coverage. So why do I mention this? Is that many a times the communication between machines goes through the web. Now with these edge servers and these technologies that are bringing private cell phone networks to farms, we're starting to see that the communication between machines doesn't need to be over radio anymore, but actually can be over the cell phone, with the traffic never leaving that particular edge server. So quite a bit of advancements. Today, many machines talk to each other via radio, but I am pretty certain that we're going to start seeing technologies such as 5G, edge computing, etc., become the way to get that connectivity, especially if you want to go to autonomy. I think that a high-speed connectivity is going to be really necessary so you can have the supervision of those machines.
So are the telecom companies involved in here in helping facilitate that edge intelligence?
Yes. AT&T, for example, is a good partner of John Deere. Sudha, thank you very much. I don't want to take anyone's time any single more minute. I just wanted to thank you for the opportunity. I hope that this was interesting. Don't forget that there is plenty of opportunity to innovate in terms of digitalization, automation, autonomy, digital twins, and others in ag, and there's lots of money to be made as well. With that, thank you.
It's fantastic. Thank you so much, Alex. We really appreciate it. Thank you so much.
All right, bye now. Have a wonderful week. Thank you.
Bye.
Yes. Sudha, feel free to pass my LinkedIn contact to your students. Some of them already connected with me, and I'm happy to answer any other questions that there may be.
So I have a habit of going back to LinkedIn, and when I put I share some of these, I come back and do like some lessons and call out as a thread. I will do that later today, time permitting. So
yep. And thank you for mentioning me there as well.
Yes.
Okay, very good.
Bye, Alex. Thank you so much for your time.
Bye.
Okay, bye.
Happy to.
Yeah. Good. Thank you, class. With that, I'm going to wrap up. And thank you, Anand and Usha and Sneha and Emmanuel. All of you were amazing. Quinzuela, it was so good to hear, and Charles, right, to see the UX connection, because we are not offering the AIX class yet again, but with the previous batch, we looked at voice UI and UX and with so many other AI. So it'll be interesting to pick that up, to see whether we can, I want to see whether our students can do a project in this space. So let's get there. So thank you, everybody. With that, I'm going to wrap up and have a beautiful rest of the week. And for those of you who are part of the path through AI space, thank you, Anand. I'm glad you liked it. So for those of you who are part of the path to AV space, I will see you in class for the business of AV data. And if you have friends who are interested in this class, please tell them to sign up and talk to me or David and for the AV master class, because we still can take in a few more students. Okay. And tomorrow's class, I will kick off and start that. And then Mr. Alexander Varga from Volvo will be co-teaching that class with me. So thank you so much. And bye, everybody. I'm going to stop my